Hi Year 12. Today what we're going to be having a look at is the sum and the product of roots. We're going to look at quadratics, cubics and quartics as well. So let's have a look at what I mean by that. Okay, so if we were to let alpha and beta be the roots of this quadratic, ax squared plus bx plus c equals 0, what we would have if alpha and beta were the roots would be this, that we would have this quadratic factorized into x minus alpha, x minus beta. Now, if I was to expand that out, I'd end up with this. And it will take a little bit of grouping together, but I'd end up with an x squared minus alpha plus beta x plus alpha beta. Now, if you want to pause the video and have a go at that, please do that. And then what I can see is, from this part here and our original quadratic, if I was to divide each term in my quadratic by a so that my leading coefficient was a 1, I'd end up with 1 here, a b over a here, and a c over a here. Now, if we now were to equate coefficients between the two that I had asterisked here, then I would have that my middle term here would be minus alpha plus beta, and my middle term here would be b over a. So they would be equal to each other, and the minus here is just popped over to the other side. My constant term alpha beta would be equal to c over a, and that's my second part here. And this is called the sum of the roots and the product of the roots. So the sum of two roots would be minus b over a, and the product of two roots would be c over a. Okay, remembering that the coefficients out the front of x squared is a, out of x is b, and the constant term is c. Now, we can use this information to help us solve some equations, and we're going to do that down below with our first example. So we're given that alpha and beta are the roots of this quadratic here. 2x squared minus 6x plus 1 is 0. So we know here that a is equal to 2, b is equal to minus 6, and c is equal to 1. And we want to find the sum of our roots, alpha plus beta. We can grab that straight from our formula up here. That is equal to minus b over a, which is going to be equal to minus 6, which is 6, over 2. So the sum of our roots is going to be 3. We could work out the product of our two roots, alpha beta. That would be straight from our formula again, which would be c over a, which would be 1 over 2, which is a half. Now, part C wants us to work out alpha squared plus beta squared. But if you have a look back at our rule, we don't have anything where we have alpha squared plus beta squared. But we do have alpha plus beta, and so we need to make alpha squared plus beta squared look like one of these two things. So I'm going to do a little bit of manipulation, and I know that we have alpha plus beta, and if I was to square that, I would end up with squaring my first term. Oops. 2 times my first times my second, and I'd square my last term. So now what I have in there is I actually have an alpha squared and a beta squared, which is what I was after. I just need to manipulate that equation to and take away the 2 alpha beta, and I'll end up with my alpha squared plus beta squared. So if I had alpha beta still all squared on the left hand side, and I took away from that the 2 alpha beta that was on the other side, so both sides of having 2 alpha beta, taken away from it. Sorry, my OneNote's just playing out there. Fix that. I'll just say that again. On the left hand side, I've got alpha plus beta all squared. If I take 2 alpha beta from both sides, on the left hand side, I've got alpha plus beta all squared minus 2 alpha beta. And on the right hand side, I've got alpha squared plus beta squared, which is what we want. But we now have something that we can work with, because alpha plus beta squared would be the square of what we got for question 1, or part A. Part A was alpha plus beta. We've got 3. We would like to square that. So that would be 3 squared. So we'll have 3 squared there. We're going to take away 2 lots of alpha beta. Alpha beta we got from the second part, which was a half. So 2 lots of a half we're going to take away. That's going to equal 3 squared is 9. Take away 1 is equal to 8. And that is equal to our alpha squared plus beta squared. Okay, part D, we've got 1 over alpha plus 1 over beta. So we need to work this into a form so we have alpha plus betas and alpha betas. So let's get them over a common denominator. So the common denominator is going to be multiplying those two together. We're going to end up with alpha beta on the bottom. So we're going to end up with beta plus alpha on the top. Okay, which we can work out. Alpha plus beta from our first question was 3. Alpha beta from our second part was a half, or is still a half, which is going to be equal to 6. Okay, let's move down to the second question here. And the example says we need to find k if alpha is equal to minus 2 and kx squared minus 7x plus k plus 1 is 0. Now, the big tip here is that they've given us a root. So we can do that probably slightly different than the product and the sum of the roots that we did for the question above, because we know that if we have a root or a 0, then p of that is equal to 0. So if I sub my minus 2 into my polynomial, I'm going to get 0. So let's sub minus 2 in here where x is, and we'll see what that falls out as. So we're going to end up with k times minus 2 squared minus 7 times minus 2 plus k plus 1. Remembering that we're substituting in for x, not for k. So what that's going to equal is 4k plus 14 plus k plus 1, and that is equal to 0. So 4k plus another k is 5k plus 15 is 0. So 5k is equal to minus 15, and therefore k is equal to minus 3. Now there are other ways to do this question. This way is the simplest way, okay? We could look at a way where we know that this being a quadratic has 2 roots or 2 zeros, and we could use our minus b over a and c over a if we would like to, knowing that one of our roots is minus 2. So you could try that, and I can show you my working for that if you would like to see me in class about that one. So I'm going to do the next part on a separate video, so the videos are a little bit shorter.